Hello everyone, we've got another A2 Edexcel question on moments. So a nice 12-mark question here. So let's have a look. It says a non-uniform rod AB has a length of 6 meters and a mass of 8 kilograms. The rod rests in equilibrium in a horizontal position on two smooth supports at C and at D, where AC is equal to 1 meter and D to B is 1 meter. So 1 meter in and 1 meter in. As shown in figure 3, the magnitude of the reaction between the rod and the support at D is twice the magnitude of the reaction between the rod and the support at C. So this force is twice this force. So we only need to express it in terms of one unknown, an idea that we've met in previous videos. The center of the mass of the rod is at G, where A to G is X. So it's at G and we're calling A to G X. So first of all, we've got to show that A to G, or in other words, the distance X, is 11/3. Now I've decided for the purpose of this initially to call this distance from C to G, I've called that Y, okay, and I'm going to add on 1 to find out X. Just I think makes life a bit easier in the calculation. So let's see what we're going to do. So first of all, we resolve vertically. And resolving vertically, we have R plus 2R equals the weight going down. So R plus 2R is equal to 8G. And then from that, we can work that out. And that gives us that our R is equal to 26.13 newtons, or 392/15. So we've resolved vertically and found out what R is. Now, what am I going to do next? Next, I need to show that that distance is equal to 11/3. Okay, so we know what R is now. So the next thing that we're going to do is we're going to take moments. Let's take moments about C. So we're going to take moments about C, and let's see what happens when we do that. When we take moments about C, the sum of our clockwise turning moments is going to equal the sum of our anti-clockwise turning moments. So we're going to have my Y distance times by 8G is equal to that distance between there and there is 4, because the whole thing has a length of 6 and there's 1 meter either end, so that distance is 4, times by 2, which is the 2 there, and the R that we found from resolving vertically. We work that out and that gives us that our Y is equal to 8/3. Now we're asked to find out what A to G is. The Y is 8/3, that is 1. So therefore A to G is 8/3 add 1, which is 11/3 as required. So that's quite a nice little first part there to get our 6 marks. Very nice bit for 6 marks. Okay, let's see what's happening now. So the next thing we're about to do is let's have a look at here's a sketch representing what's going on for part B, and let's just read the information. So the support at C is now moved to a point F. There it is. Where A to F is 2 meters. So it was formerly there at 1 meter. It's been moved in by another meter. A particle of mass 3 kilograms, so that's 3G, there is now placed at A. The rod remains in horizontal and in equilibrium, and the magnitude of the reaction at D is K times the reaction at F. So here we've got a reaction at F, RF, and I've written this one as K times RF, okay? So that's our kind of sketch for that first bit. Okay, perfect. Right, so let's think about what we're going to do to start off with then. So first of all, we are going to resolve vertically. So we've got our sketch, let us resolve vertically. So when we resolve vertically now, what have we got? We have got RF plus K times RF. So the force is going up equal the force is going down, which is our 8G plus our 3G. So we've got that RF plus K times RF is equal to 11G. Okay, now I'm going to park that equation there because it's got 2 unknowns in there, so we can't do anything immediately with that straight away in the first instance. Let us now find an expression. We're going to take moments, and I think it would make sense in this case for us to take moments about F. So we're now going to take moments about F. Let's do that. So moments about f. So we've got the sum of our clockwise turning moments is going to equal the sum of our anti-clockwise turning moments. And when we take moments about f, what have we got here? Let's think about this. So we know this distance here is 11/3. We know that that is 2. So this distance must be 11/3, take away 2, which is 5/3. So we have 5/3 times by 8g. That is a clockwise turning moment. And then our anti-clockwise turning moments are, we have 3 meters times by our KRF. And we've also got an anti-clockwise turning moment here from this weight, which is 3g. So that is 2 times by 3g, because the distance is 2 there. Perfect. So we can now basically rearrange this equation in order to make KRF the subject. So we're going to have 5/3, so 5/3 times by 8g, and take away from that 6g. Okay, and then we're going to divide that by 3. So that gives us an expression that our KRF is equal to 1078/45. Okay, that's great. Now, what we're going to do now is we're going to take this value of KRF, sub it into this equation up here, and that will enable us to find out what RF is. So we have RF is equal to our our RF plus our KRF, which we found to be 1078/45 equals 11g. So from this, we can find an expression for what RF is. So we're going to do 11, let's do 11g, so 11 times by 9.8, 11 times by 9.8 minus our 1078/45 gives us that RF is 3773/45. And now finally, I'm going to take that value and sub it into this equation here so that we can now find out what K is. So I'll just rewrite the equation again. So we have RF plus KRF is equal to 11g. And we now know that this is 3773/45 plus K times 3773/45 equals 11g. So I'm just going to basically rearrange this now to make K the subject. So 11 times 9.8 is that, minus our answer. Let's do that again. So we're going to do 11 times by 9.8 minus our 3773/45. Okay, and then we're going to divide that by the 3773/45. And when we do that, we find out we get that that is 2/7. So we find out that K is equal to 2/7. And that is our final answer for that question. A little bit trickier, that moment question, I think. I hope you found that helpful, and I will see you in the next video.